Hi, I'm Jacques Favreau. I'm a senior engineer at Netflix, and I've been there for just about 6 years now. I worked on the member web experience, the web platform, and most recently in the acquisition space. So if you are on Netflix and haven't clicked login yet, that's my stuff. I want to tell you a story about legacy upgrades, about refactoring, about a year-long process to replace a single function, and how so much of the work turned out not to be about shifting code around. At some point or another, all of us engineer types end up having to migrate existing code and patterns, and hopefully my story and the pieces I picked up along the way can help you make your next large change more successful and less fraught. My story begins with this function. This was the localization function for all UI text on Netflix.com. And I know, it seems really not that bad, right? All it does is take two identifiers, a bundle name and a key, and it spits out a translated UI string. So why bother changing it? Well, let me tell you. Before I jump in, at Netflix, we use React extensively, but if you're not a React person, don't worry at all. You can read this as a function that returns a chunk of what will become HTML. We're pulling the star of our show, the GetI18N function, off of a shared context. You can think of it like pulling it off of a global or fancy window object. The GetI18N String function then takes a bundle name, which references this someBundle.json file with all of our English strings in it, and then a second parameter that's the key, basically what string we want to get out of that file. So we have our localized string, and it goes off to be rendered into a web page. Neat. This API was designed 15 or 20 years ago when Netflix.com ran on Java servers, and everything was rendered on the server side, and all of the translated strings were just there on disk. But then, 6 years ago, it was ported to React and served from Node, and all of a sudden, for the client-side stuff, we had to answer the question, what goes over the wire? We don't want to ship thousands of strings over the wire just for a sign-in page that needs 10. The solution was hanging this odd meta object off the component. This is not a React thing, it's just a workaround. That lets the file declare what strings it's going to need. And at build time, we have some tooling to generate a lookup table so that when a request comes in that uses this file, we'll know to make sure that those needed UI strings are included in the bundle over the wire. So we have a build time declaration in the meta section, and then at runtime, the localized version of those strings have already been sent, and they're available on the client to be accessed by GetI18N String. It's clunky and not very discoverable, but is it worth churning the whole code base just for that? Probably not. Where it goes off the rails is actually hidden in the API implementation. See, I mentioned that GetI18N String was based on a Java API, and somebody back then wanted to always return a string. So if the combination of bundle and key doesn't map to an actual value, if you flubbed your key spelling or your logic's wrong or translations aren't back yet, you get an empty string instead of knocking over your Java server with an exception. But then along comes JavaScript. And all of a sudden, empty string is falsy, which leads to this explosion of different ways to use this API. There are if statements, there are for loops to generate permutations of keys to try. There's my personal nemesis taking the output from a network API call and using it as a key to see if a string exists. All over the code base, we have multiple years of people building UIs on top of empty, falsy strings. And knowing the history of this API and the good folks who are working in this code base, I understand how we got here. None of it's malicious or a lack of technical skill. The API doesn't feel like the worst thing. But it is. Because there's no detectable difference between the intended use that results in an empty string and a bug with a missing string or a failed translation or anything that results in not getting a string to our user. All you get out is empty string. This isn't bad architecture, it's just solving something with a different set of constraints. When this was a Java service run by 10 people and they pushed once or twice a month, somebody was going to notice a missing string. But now, 80 people adding code that gets shipped multiple times a week, we're not going to find that in time. Our constraints have changed, and now we have a problem. because there's no possible way of alerting or linting or warning or anything, because as far as that function can tell, a bug accidentally resulting in a missing string is the exact same as somebody relying on empty strings for the logic in their code. So is it the good empty string or the bad empty string? And that's the value we're after. If we can replace this with something that's observable, where failing to load a string is not part of the normal procedure, we can have dev time, build time, even runtime alerting, and we can make sure that our translations are fully available. We can get to faster pushes with better product stability. And all of that, that's worth the time investment. So let's fix it. As an engineer looking at legacy modernization or brownfield project, and I'm guessing many of you, initially see it as proposing the right technical solution and then executing on it. That stuff is like catnip to engineers. And yeah, there are small isolated problems where that's the right approach. But as the scale of our problems grow and as our proposals impact more and more people, our path toward success starts to look a lot more like, well, this. At a large macro view, you can see the majority of what got added there were people-centric things, not code-centric. And honestly, even the code-centric tasks have a lot of human interaction. It's really easy to focus on the code side because it has explicit, testable outcomes. But for large-scale, high-touch refactoring, I found that literally every time I didn't put an appropriate amount of work into the people portions, my project suffered for it. Working in a code base is a social activity, and throwing everybody overboard and relying on the perfect technical solution to speak for itself, that is not the way. Instead, we have to spend time communicating, bringing people along, and selling them on the value of our changes. Folks just want to write their code and get their features out. They already know how to do that. They might not even be able to see the problem we're working to solve. So if we're changing things out from under them, it's worth putting time in to build an empathetic approach. Otherwise, our change is just a roadblock to them doing their job. Now, I'll be the first to admit that I certainly don't bat 1,000 here. The right balance between code work and human work, it shifts with every project. And learning how much something calls for, that's a skill that we learn by doing. But keeping an empathetic approach sets us on the right path to landing a successful change with the support of our team. And that human-centered approach starts off with how we define our problem, how we discuss the value of getting it fixed. I already introduced the core of the strings problem. There's no detectable difference between bugs and working code. That's unsafe. That hits engineers. Every single engineer has or will run into this at some point. It can quite immediately degrade a product. It can even break the website without us knowing. And everybody suffers as we slow down our push schedule to thread the needle between speed and risk. We'll have a technical fix, but framing it as human impact lets us more easily discuss it with other engineers or product folk, and it means we can build consensus that a problem exists and then also collectively get excited about fixing it. Speaking of other people, now that we have a good idea of what we want to talk about and how we want to talk about it, it's time to gather our voices. I've found in this project and many others that having the right small group of initial voices, people who can represent the different groups or users in a code base, that will drastically increase the chances of a successful project. It might save time working if you're working on a solution that ends up not fitting use cases, or any number of things that you might not be aware of. For me on this project, it was a lot. The other thing this helps you do is build a core group of people who become very familiar with not only the problem, but also what solving it might provide. In something like the strings project, I'm proposing it to change how literally every engineer mentally models things and interacts with the codebase. I'm asking every single person to learn something new and give up something they already know how to do. Having a set of folks on the ground who know the benefits of the change will help shift the engineers in that moment of frustration from why did they mess up my code to, hey, this isn't so bad and it gives me something great in exchange. So this group your advisors, and your street team, they're important. The point is to get voices and experiences that aren't just your own, and then also to set them up to help evangelize the big change. So, we have our group on board, and now we have to figure out what to do. Sometimes technical solutions spring fully formed into existence. You know what you're going to do, and you know how you want to do it. But other times, things are more tangled. My localized string here, that's one of those tangled messes. There were just so many connected systems, from the build tools to the translation pipelines to the actual code and all the many ways it's used. Trying to change everything in one blinding flash is extremely high risk. So if we're working on a significantly large project like this one, I'd highly recommend trying out a version of the Strangler fig pattern, where, sort of just like its namesake, we grow our new solution alongside and then around the old one and slowly move functionality over and over to the new one until nothing's left in the old and we can just sweep it away. And beware, the allure of the full rewrite is always there. Marianne Bellotti mentions this in her excellent book on managing aging systems. She says, rewrites maintain an attractive level of ambiguity, while the existing systems are well known and therefore boring. I'm not gonna lie, I thought about redoing the whole system a lot. In the end, I ended up targeting an intermediate solution built on top of the existing infrastructure, but separating out the two core ideas. These are the strings I'm going to need. That went into one function called require string, like nodes require, but for strings. And that returns an object that can then be passed to the second function, format string, to produce a normal localized UI string at runtime. The require string is statically analyzable in the same way that import or require statements can be analyzed by something like Webpack or a bundler. So we can answer that build time question about what strings this file uses. And format string, that gets us the actual translated string at runtime. Most importantly, though, these two functions expect to succeed. If you give require string a bad bundle or a bad key, or hand format string a bad object, they alert in production and they throw on a developer box. That means we can catch errors at develop time, at build time, or even at runtime. And that gets us the observability we wanted. However, every change is a trade-off. Many of the existing components didn't have explicit knowledge of the exact strings they were using, and with this change, we'll have to go spelunking to dig those out. That means changing a lot of code and also changing a lot of the ways that people think about that code. And with such a large change, it's worth double checking we haven't missed anything. Remember our core group? Well, they know the problem space better than the rest of the team because we already talked about it a lot. And these folks can help us out here. Remember, getting halfway through a migration only to find out that there's an unsolvable problem is rough. As a note, I didn't do this part right my first attempt. I started a migration that wouldn't have worked for a whole chunk of the code base, and I just didn't know about it. It got caught before the large-scale changes, so I got lucky. But get that review coverage. So, we iron things out, we get our green light from these wonderful people, and we are off to the races to tell more people. We are almost to code. But this is a big project, and it can't succeed if we don't bring all of our people along with us. I know that marketing and engineering can, in some cases, not be the closest of friends. But at its core, marketing is about showing people value where they didn't know it existed. And that's important. If we're going to change a bunch of things out from under developers, we're asking folks to change how they work, to stop what they're doing and learn our new thing. Also, there's probably going to be merge conflicts along the way and who knows what else. We want the broader team to know that it's worth the pain, to sort of hype the value about what we're going to get if we get there, when we get there. For me, this was a platform-wide email and a slot in a cross-functional team meeting so that at the end of the day, folks at least were aware of the oncoming storm and hopefully a little excited to get what's on the other side. And with that, let's change some code. Unfortunately, as with almost all refactoring or migration, you end up with way more complexity than you anticipate. To give ourselves a fighting chance, we can use the Mikado method. The core idea is that we approach in-place refactoring like you play Mikado or pickup sticks. There's one stick that's worth a ton of points, but there are lesser value sticks on top of it, and you can only remove one stick at a time, and you got to make sure not to disturb the rest. For us, in software, this is starting at a goal and working backwards through the intermediary steps to build up a path that then we can walk forward on. If at any point we break things or run into something that's too complex to deal with, we stop what we're doing and figure out what sticks we can move to get us back on track. Ideally, it means we can do these in small changes without having to modify everything all at once. It's easier to find bugs, merge, and even revert smaller changes, and you get manageable pieces to work with sort of along our upgrade path. If that tickles your brain, Ola Elnestrom and Daniel Brodlin, who came up with the formal idea of the Mikado method, they wrote a book about it, and you should definitely check it out. For the strings project, we start with our goal. We want the two new functions to be the only way to localize strings. And then we work backwards. So what's in the way of that? Well, the code needs to be updated. And before that, we need the two functions to exist. And even before that, we need our build tooling to recognize require string in the same way it recognizes the meta section today. So going bottom up, the first two steps went smoothly, but when we get to updating the code base, tens, maybe hundreds of changes are manually doable, but thousands, we're going to need something better than find and replace. So let's take that update the code base and make it our goal and see if we can figure out how to move the sticks off of it. We know there's going to be some manual work and then cleanup, but before that, the hurdle is that there are just more updates than we could do manually. At this scale, it's worth checking out Codemods. Codemod is a programmatic way to transform one syntax into another, and it allows us to change a huge number of files with a level of control that we just can't get with find and replace. There are a few different tools that you can use. There's JS CodeShift, Babel, and even ESLint. They're all doing pretty much the same thing. They parse our file into what's called an abstract syntax tree, or AST. There is a great website, astexplorer.net, that lets you paste in a chunk of code and then browse the AST structure that's created. So they parse it into an AST, and once the file is parsed, we can run code on the tree instead of just on the raw characters of the original file. In fact, if you want to try it out, you can turn on transform in AST Explorer and write your own code mod right there in the browser. The future is wild. If you're interested in learning more about Codemods, Laurie Barth has a great article on Egghead and a whole course with John Otander on compilers in general over at compilersforhumans.com. Of note, I've almost never worked with a code mod that got everything in one shot. It's just not worth it unless you're working on astronomical scales. The goal here is to get us as good as we can before diminishing returns kick in. If we can take this from thousands and thousands of invocations to a couple hundred, that's a win. So we get that code mod, we land a series of pull requests that modify all the invocations we can handle, and then a curious thing happens. Our new, beautiful API is in place, and people still are using the old one. They're adding the old one. And of course they are. That's the one they know. They might not have read the email, they might not have been in the meeting, they might just not be thinking about it, or maybe they feel unsure about the new API. But it's going to be really frustrating when they put working code up for review and then get asked to redo it in a new style. That's a bummer, and it builds no great sense of endearment for our migration, because the right time to have been told about it was as they were writing their code. However, it is possible to give them that dev time feedback. ESLint is exactly that. If you haven't used ESLint before, it's an excellent code quality tool. And I've heard some hate for ESLint over the years, but I think a lot of that is from when rules are enforced without motivation or empathy. Who wants to be told you're doing it wrong if there's no reason provided why that's wrong? Instead, we can develop our lint rules as guidelines to the developer, and keeping that developer in mind to use sort of as a dev time assistant. Sort of, hey, that thing you just typed, that's the old version, and we're just going to have to replace that next week. Instead, here's a link to the docs and examples of all the new functionality and a contact person to reach out to if you get stuck. That's helpful. That's developer-centric, and it gives the context and it connects the dev to a person who can actually answer their questions. Writing lint rules is not hard, but it is a skill to learn. However, ESLint ships with a couple rules that can be configured to target arbitrary code and throw out custom messages without having to write your own rules from scratch. I used the no restricted syntax rule to target function calls named GetI18N String. The rule is configured with a query, sort of similar to how we write CSS selectors, but instead of against CSS, it's against an abstract syntax tree. When any code matches that query, the developer gets to see the warning right in their IDE. Part of making slow migrations work is making sure all the engineers know how to move to the new functionality with as little frustration as possible. And I have found extremely good luck with the distributed and sort of dev time feedback that ESLint can provide. So now the bulk of our change has gone through. Our engineers are adding or even updating some of the remaining instances as they come across them. And it's time for, well, truthfully, the slog. Manual changes aren't fun. I had to get help for areas that were particularly tangled up or in mission critical portions of the site that I didn't know well enough to change. But here's where all that people-centric work we've been talking about comes back to pay dividends. We have a large and growing group of people who see the value of the change and are excited, or at least supportive, of getting it done. So while it's never a slam dunk to go around asking managers for resources to help with a migration, we're in a much better spot than if we were migrating or just coming to this cold. Another thing that will help is clearly defining all of the remaining places that need an update. And, oh hey, we just got an ESLint rule that'll help us find all of them. So grab the output from that ESLint, make up a bunch of tickets, and have folks start churning through it. It took a while, but we got there. So now we've got all the places we can find taken care of, but is there anything lurking in the shadows? Any patterns we didn't anticipate or things we just missed? We now get to do one of my favorite things, which is lace up an old function with motion sensors. If we're pretty sure but not positive that a function is no longer in use, we can, while still safely keeping it around for prod, make it very loud if it's used, alerting if it's in production, or straight up throwing on a dev box. With my contact info in the error message. We're expecting this never to happen, but it's always good to check. For my project, it blew up a couple times and was definitely well worth the 4-line PR and waiting around for a couple weeks. And there, finally, we've done it. We can remove the old functions, communicate, again, the awesome benefits of the work that opened up for the team, and thank all the people who helped us get here and be done. We started off with a technical problem, an unobservable, unreliable function. And while we did fix the tech side, it was inextricably linked to the people who we got help from and also the people who we impacted along the way. The people are important. From how we talk about technical problems to getting feedback from others to the APIs we design, the way we actually go about changing our code, so much of it is about people. All legacy migrations and refactors are in service of the people working in that code base or who use that product. The tech is fun and exciting, but success, especially at the larger scale, is about building with your team instead of against them. Motivating our changes to the team and bringing people along with us means support and encouragement for our current project, but maybe even more importantly, it builds trust in the team, and that when we're making these big changes in the future, it's for a good reason. That makes the next big project even easier. Thanks very much.
All right. Wow. Thank you, Jacques. Quick note for everybody. There are links to the resources you mentioned over in the Q&A on Discord, and I suggest you check it out. And there's also, some really, a lot of people going, thank you so much for that AMA. So, a couple questions here. First, you mentioned you wanted strings to eventually be just in the files that use them, not in JSON bundles. Is that some future work?
Yeah, so it's actually work that's going on right now. So this project was a couple years ago now, and there were some of those sort of pickup sticks that were in the way of getting to that sort of ultimate idea of I just want to write text into my UI files and use them. So that work is actually, all those pickup sticks have been removed over the last year and a half or so, and now some folks who are on the platform team and generally around that are actually working on it, and I'm really excited to see that finally land. The other thing is that because the API we used was so crisp, there was really only one way to use it. The Codemods that are doing that are expected to take on the order of like a week instead of a year. So I'm very happy to see that land.
Okay. And, you talk about the rethinking, the refactoring. How do things change with different team sizes?
Yeah. So I mean, it's going to be different for literally every team, right? I mean, it's all about finding kind of the path for yours. If it's on a much smaller team, you might, if it's 3 people or 5 people, you can just say, hey, this is what I am proposing. This is why I'm doing it. You can get all of those things sort of out of the way. Everybody's going to know why it's happening. On slightly larger teams, you have to start leaning more into that communication side of things. Really, independent of the team size, as long as you're sort of tacking to that North Star of make sure we bring along all of the people, all of the engineers with us, that's going to lead to the best possible outcome, because you'll have the fewest people who are sitting there going like, why did you break my day? Like, I was going to do something today and you came along and broke it. So if you can minimize that, and by doing that, you really bring people along, you let them see the value of what's happening. That makes coding in that environment a lot nicer, a lot friendlier, a lot less combative. So independent of the size, lean heavily into, bringing people along however you can.
Okay, awesome. Well, thank you so much, Jacques. And before I hand off to Carter for some pre-lunch announcements, I do have to tell one dad joke. So, how did the programmer get out of jail? He used his escape key. All right, and I'm handing it over to you, Carter.